Welcome, thanks for joining. This is my first Twitch streaming with Manny. I hope you will enjoy it. Today I'm gonna talk about how Spring Boot integrate well with Kubernetes. So we're gonna look at how basically out of the box a Spring Boot application can be naturally deployed on a Kubernetes environment. We'll go step by step. It will be a hands-on session, so I will do live coding all the time. Starting from a Spring Boot application, we'll see how to Dockerize it, so how to package it as a container. We're gonna deploy it on Docker and finally on a Kubernetes cluster. So we're gonna look at different things like configuration, service discovery, liveness and readiness probes, and also some tips about how to establish your local development workflow when you work with Kubernetes. About me, I'm the author of the book Cloud Native Spring in Action that is available in early access on the Manning website. Having said that, let's get started right away. I'm gonna code in IntelliJ. So the starting point for any Spring project is start.spring.io, of course. And here I'm gonna select the Gradle project, the latest production-ready version of Spring Boot. I'm gonna set some parameters here. We're gonna build a demo service application. I'm gonna use Java 11, and as dependency, I'll pick reactive web, then actuator, Lombok, and the configuration processor. So the reactive web dependency contains all the libraries to build a reactive web application. In particular, we're interested in exposing the REST API, and by default we get a NADI server. Spring Boot actuator is very, very useful in production because it exposes a lot of different information. So it gives us a lot of visibility into what is happening inside the application. Lombok is a convenient library to reduce some boilerplate code, like to establish getters, setters, and constructors. And finally, the Spring configuration processor that we're gonna use on the IDE just as a convenient way of generating metadata. That's it. I'm gonna generate the project. Yes, and I'm gonna open it up in IntelliJ. So the actual content of a Spring Boot application doesn't change the capability of being deployed on Kubernetes, so we're gonna do something simple. Let's give it a second to build the project. So locally, I'm using SDK-man. It's a very convenient tool that I recommend to manage different Java versions. You can install it on Mac, Linux, and also Windows. You can select different OpenJDK versions from different vendors, and you can have different versions of the JDK. It's very convenient if you're working on maybe testing compatibility with Java 11 or 15. It's a very seamless experience. That's what I'm using. Let's double check. Yeah, exactly. So I want to use Java 11. And this is just a standard Spring Boot application. We get the auto-generated files in the starter project. We have the entry point to the application. We have a property file. I will change it to YAML because I usually prefer working with YAML. So I'm gonna rename it to application YAML. Yes. And then a test just to verify that the context is loaded correctly. All right. So the first thing that we're gonna do is defining a custom property. It will help us demonstrating different configuration scenarios, both in Docker and in Kubernetes. So what I'm gonna do is creating a configuration bin I'll call it demo properties. And in Spring Boot, we can use the annotation configuration properties. This will define this bin as a configuration. And in order for the framework to actually be aware of this bin, I have to annotate the application to scan the configuration properties. And there's an annotation for that. I have to define a prefix, so all the configuration properties starting with this prefix will be serialized into this bin. It will contain only one property, let's call it message. And here I'm going to use Lombok to generate getters, setters, and constructors. Now, a nice thing about the last dependency that I added to the project, the configuration processor, is that it can generate metadata for custom properties automatically. So if I add a comment here saying, for example, a welcome message to the user, and then I build the project from Gradle, what happens is that the IDE will help me using these custom properties, just like any other properties. And there's something happening here. Sorry about that. Yes. All right. So now I can use my property. So with this prefix, the final property will be called demo.message. So I can go and say demo, and this is YAML, of course, message. This will be maybe welcome to Spring Boot. All right. Yes. Next, let's define a REST endpoint that we can use to do a test on Kubernetes. I can use here a traditional REST controller, but I can also go with a different approach that is now available both for Spring MVC and Spring Webflux, that is relying on some functional endpoints instead of REST controllers. So what I'm going to do now is defining a bin here. That will return a router function of server response. And here I can say return route, and then I can define a get endpoint. A get on the root, so just slash, and then in here I can use a lambda to return something. And since we are using Spring Reactive, this is gonna be a reactive object, so it can be either mono or flux. In this case it's just a single value because we want to return the message, so I'm gonna use the mono. And this is server response dot OK. Now in the body we want to use the property that we have defined in the bin. So I'm gonna do this. I'm gonna inject the properties bin and define a mono with just this value. Dot get message, and this contains a type of string. What's the issue here? Oh no, this is Oh, that's why. Come on, okay. Router functions dot route. Okay. And then get, and we have request, yes. And build. All right. So this is it. Simple application will return a message that we define through a custom property. So we can directly run it. By default, it will run on port 88. So let's see. I'm gonna go with the boot run. So the boot run task is building the application as a jar artifact. That's one of the nice things about Spring Boot, that jar artifact can run everywhere as long as you have a JVM, and that's the starting point to build a Docker image. This is the application running. And let's see if it's working. 8080. Here it is. Welcome to Spring Boot. Here I'm using a little tool that is called HTTPy, if you're interested. It's very convenient. I prefer it compared to curl because yeah, it's much more intuitive. So I recommend you give it a try if you use very often the command line. Yes. So one last thing before we move on to containerize the application that I want to show is that whenever we build the application, we get a jar file that for Gradle is under build libs. So instead of using the boot run task, I could directly run the jar file from here, pointing to that path, build libs, and then the jar. And that's it. So from this point on, so we have a very simple Spring Boot application. It could actually be complex. It doesn't matter what you have inside, because the next step, it doesn't involve changing anything in your code. Containerizing a Spring Boot application since version 2.3 is actually very, very simple. You don't need to create a Docker file. You don't need to import any external plugin, but directly in your Spring Boot plugin for Gradle or Maven, so the one that you are already using to build your application, you can also build a Docker image. No Docker file, no extra files. And in Gradle is called boot build image. That's a similar task in Maven, same functionality. And by default, this task will generate an image that is called like the project, in this case demo service. But we can customize it. Usually it's better. So in Gradle it's gonna be in build.gradle, but in Maven you're gonna do this in the pom.xml file. At least two things that you would probably want to do is defining the image name. And since I wanna push this image to my Docker Hub repository, I'm gonna use my username on Docker Hub. That is also my repository name. And then instead of hard coding the name of the application and the version, I'm gonna use the variable substitution in Gradle. So I'm gonna use the project.name, that is the demo service, column, and then demo.version. not demo, sorry, project.version. That is the version defined up here. The next thing I'd like to do is to be explicit about which version of the JDK I want to use. In this case, I'm using Java 11. So I can define that by passing some environment variables here. This means that I'm getting the last Java 11 version. Let's run it, and then I explain the syntax and what does this mean. First, I'll stop the application that is running a jar file. I'll start the task. And while that is running, I'll explain what is happening under the hood. So I'll go to buildpacks.io. This is the tool that is implemented inside the Spring Boot plugin for Gradle and Maven. This is a specification. This project is part of the Cloud Native Foundation. And Spring is using an implementation that is called Paketo. This buildpack specification works in a way that it detects what are you using in your project, and then it maps what you're using with existing recipes to build images. So in the case of Spring Boot, it will detect that is a Gradle project first, and also that is using Spring Boot. So it will use a builder image that contains these structures to build a good Docker image around Spring Boot. The implementation is Paketo. If you're interested, you can find in the Paketo buildpacks documentation all the configuration properties that you can specify. So like this environment variable here is specified there. BP stands for buildpacks. Yes, the task run correctly. Let's have a look. So the image that has been built is named like this. Docker.io is the registry name that is prefixed for all images on Docker Hub, and then the name that is specified. You can see, if you're interested, all the steps and all the things that this builder is providing is not just the jar file and the JVM, but is providing several different utilities like certificate configuration. And one thing that I like is the memory calculator. So it computes at runtime, depending on the deployment environment, it computes how much memory to configure for the JVM to run. And now I can take this image and push it to my Docker registry if I want to. Now I'm doing this manually, but actually this task has also a possibility to specify the configuration for pushing the image for you directly. You can do that by using this configuration. And then you specify a username and a password and the URL for the registry. Now, this is called password, but I really recommend not to use a password. So if you're using Docker Hub, but also for other registry, you can generate a token, a single purpose token that you can control better than the password. You should never expose your password or put your password anywhere. So this one is your username, but instead of the password, just use a token. If you're using Docker Hub, you can find instructions in your profile settings about how to generate a token. And then the URL that, in the case of Docker, would be docker.io. Once you have this configuration, and I'm getting some parentheses issues. So let's write something. So this is the username, this is the token. Once you have this, you can still run the same task, but when you want to also push the image, you can run put build image, and then you specify also a parameter that is publish image. Yes. So we have a Docker image. Before moving on to Kubernetes, let's see first if it works. I'll remove this because I'm not going to use it. And I'll use a Docker compose file to do that. This is called demo service. And the image name is shown here. Yes, you can define container name, demo service, and let's publish ports. Let's keep 8080 8080. Okay. Let's see if it works. And it failed. All right, let's see what's happening there. Okay. Let's do like this. Some cache issues with IntelliJ probably. Yes, here we have it. So first of all, I can check the logs. Demo service. So you can see here how it's calculating the JVM memory based on my on the resource available on my computer. Let's see when it's starting. So it will first run some pre-configuration for the JVM, and then we'll start the application. At this point, let's see if it's still working. Port 8080, root endpoint. Welcome to Spring Boot. Now, since we are running in a Docker container, we could actually override that application property. There's different ways to override configuration in Spring. Usually you have in your application YAML or property file some default values, and maybe it acts also as a specification of what is possible to configure, and then you override it with different ways. One way is to use environment variables, and we can do that directly in the Docker compose file here. I can specify an environment variable to override the demo message property. The convention in Spring is that if you have a property like this, so it's demo.message, right? Environment variables are usually all uppercases, so we'll transform this property name into all uppercase letters, and then we convert the dots into underscores. So this property will become demo underscore message, all uppercases and with the underscore. And this can be equal to welcome to Spring Boot on Docker. All right, and finally, let's update the application. and it started correctly. So now we can go okay, now it started. So we can go, and now we should get the new value that we specified with the environment variable. Here it is. Welcome to Spring Boot on Docker. All right, that's perfect. Let's remove this, compose down. So if we sum up what we have done so far, we wrote a simple Spring Boot application. There was nothing in there about where the application is deployed. The only thing that we did to containerize it and deploy it to a Docker environment was to use external commands. So with boot build image, we built an image, and then with the traditional Docker compose or Docker CLI, we can start the container. So the application didn't change. And then we saw also a way to override properties through environment variables with Docker if we want to customize the configuration.